Like, so what I'm saying, your design will be for now, for few next classes, your design is going to be what, there are some end devices. End devices can be PC, server, printer, IP phone, right? And those all end devices are connected with one switch, and switch is connected with one router, and router is connected with one firewall, and firewall is connected with ISP, like this. For now, just keep in mind this design, right? Try to understand about the devices and the configuration to provide internet connectivity to end user. Like, let's say there are some computers, servers, right, printer, IP phone, like this, and these all devices are connected through one switch. Or you can assume that few devices are connected through what, AP, and this AP is connected with what, switch. These two devices are connected through radio frequency. Then switch is connected with what, one router, and router is connected with one what, one firewall, and the firewall is connected with what, ISP. So first we are going to understand everything on the behalf of this topology. Like, if we are talking about OSI model, right? So I will discuss only this part in this topology. This is my complete topology for maybe next 10 days. Getting my point? Like, here I am going to make you understand what is router, what is firewall, right? What is ISP, what is switch, what is AP. Then what configuration is required on switch, what configuration is required on AP, what configuration is required on NAT, and what configuration is required on firewall, so that these user can access internet in secure environment. In secure environment, like there is one attacker on ISP, and if this attacker will try to enter in my network, right, my firewall should not be allowing any unwanted traffic. My firewall will be blocking traffic of attackers. So you need to configure this firewall in such a way that it will allow traffic of these user, right? Trusted traffic only, you can say. Maybe you need to configure firewall in such a way so that whenever these user will send a request to internet, it will allow to reply, but whenever any request will come from outside, it will block that. I can tell to my firewall, right? Like, I have to tell to my router that whenever someone will send request for internet, you have to forward the packet to firewall. I have to tell to firewall, please check the traffic which you are receiving, right? Compare it with your table and then decide to whom you need to forward this traffic, right? After that, maybe firewall will forward to ISP. On the ISP, there are server that will generate reply, or maybe attacker that will generate reply, right? So if attacker is generating reply, your firewall will block it. If genuine person is replying, your firewall will allow that traffic to enter your network. But when someone from outside, attacker, if attacker will try to access this server, firewall will not allow it. Like that. This is, guys, very basic simple task of firewall, right? This firewall can do lots of tasks, and for each task you have to run a command on router, sometimes few commands on router, sorry, on firewall, in the same way on router. Then, as I told you in last class, that this is public network and this is private network. So by default, private network and public network can not communicate with each other. So I have to tell to router to translate as well, right? What you need to translate traffic when you will receive, on this interface, on your inside interface. What you need to translate when you will receive traffic on outside interface. We have to tell everything to routers. Like on this PC, I have to tell this PC, brother, your IP address is this one. Or you can tell to PC, please ask your IP address from DHCP server. So in your network, there will be one DHCP server as well. Like I'm saying, this is server. So let's assume this is DHCP server. And you know what is DHCP server? So DHCP server is responsible to provide IP address to end machine dynamically. Dynamically. Like in my computer, if I will run command, so, not so, IP config all, let's say, IP config all. Let me check it's showing me method or not here. What it's saying, DHCP is means my PC have got this IP address from DHCP server only. I have not configured it manually. So there are two options to configure IP address on machine. Either you can configure it manually or you can set up a DHCP server in your network, right? So in this network there are one DHCP server as well. So these are guys what configuration on devices. So first try to understand this design only, then maybe you will have one same branch in different location. Like here also you have one switch, then you have some AND devices, AP, those devices are connected with switch, and switch is connected with router, router is connected with what, again ISP. And as you know, these two both ISPs are connected with each other, both ISPs are connected with each other, that is what internet. Now here how you can make communication possible between these two private network. Now you have to configure one virtual link between, you can create it between firewall to firewall or between router to router. There is your firewall. So here you have to configure one tunnel, right? That is VPN, virtual private network. So our public network, now you have created one virtual network, that is overlay network. On this virtual interface again you can configure IP addresses, and through that you can make communication possible between these two branches together. So first guys, this design, yes Chandra.
What is you're telling you need to make tunnel? What is mean tunnel?
Tunnel is nothing but one virtual link between your firewall to firewall or between a router to router. Virtual link means what? Virtual link means logical link.
Without physically.
Correct. Correct.
Then how it will communicate without physical?
Actually, this is here the IP address which you will run is what, public, because ISP is connected with this interface, correct?
Yeah.
So ISP is going to provide you public IP address. Here also ISP is going to provide you public IP address, right? And these two public IP addresses are reachable with each other. So through this public IP address you can create one tunnel, right? And or through this tunnel interface you can share your private network, you can share your data. Again your data will flow from the ISP only, from the physical link only. But to make communication possible between two private network, you have to use, this is one, you know what, option. We have one option, this one is option to make communication between two private network or public network. Getting my point? So first guys, we will understand this design. Like in my network there are some end devices, one switch, and switch is connected with router, router is connected with firewall, and firewall is connected with ISP. Then we will do same design on other side. In between we will put some ISP, few ISPs, and then we will see the configuration. So here when I will make you understand this design guys, this part, your private network, I don't need to teach you this side again, same private network you can design. Then you only need to understand the connectivity between this point to this point, and after that we will move to next design, other design. Okay, because here we don't have redundancy. Let's say if my firewall goes down, then what will happen? Can this user access internet? Can this user communicate with remote branch user? No, because we don't have another link, we don't have any backup link, right? What if router will goes down, or what if switch will goes down? So for each devices we need what, redundancy as well, backup as well. Because as I told you, just assume network of airport, how critical it is. Every time their server should be accessible from anywhere. If you are booking a ticket on a SpiceJet website, and just assume that from last 10 minutes you are trying to book ticket but you are not able to book it, right? So network design, network availability is very important for customer, and as a network engineer you have to take care about it. So as you are going to take care of network, you have to learn each and everything about the devices and about the configuration. Because if you don't know what is the configuration on these devices, do you think, guys, if problem will come, you will troubleshoot it? No, because you don't know the configuration. You can do only troubleshooting of physical, like physical devices, physical link. You can replace it, right? You can change the devices. Only you can do this work. Getting my point? So configuration is very important. How to configure the devices, and at the same time, while configuring, we will create problem as well, and then we will see how we can troubleshoot that problem. I'm telling you guys all about the real time based scenario. I'm going to tell you all the scenario which are based on real time. Within my experience, I have designed all topology for you, and those all are real time based topologies. Whatever problem I am going to create, right, same problem I have faced in the live network. Okay, so try to guys pay attention here in the class, because these are first few classes are very important, first 10 classes. Okay, so in last class we understand like this, what is network, what is the structure of network. Then we discuss what advantage of network, types of network. How many types of network are there? LAN.
LAN, WAN, MAN, CAM, PAN.
Okay, let's assume LAN and WAN. How many users can be there in one LAN?
Depend upon area.
Yeah, we divide network on the basis of area, right? So if we are implementing a network in a small geographical area, that can be known as by LAN. And what is WAN?
WAN is wide area network that is for to connect.
You can say what you know, in simple word, you can say WAN is a wide area network. Whenever we are connecting two network together with the help of service provider, through any provider, you can say that network can be known as by WAN. Getting my point? Like in my design, there are some computers. These computers are connected with which device, guys? What is the name of this device? Switch,
Switch,
right? Switch is connected to what?
router.
Router. This is what? LAN. When I am going to provide internet connectivity to these user, I have to connect this router to ISP. This network is which network? WAN. Okay, then we discussed what types of communication. How many types of communication are there?
So we have
Three. First one is
simplex.
no types of communication, that is modes of communication.
Okay.
How communication will happen? Types of communication. How many types of communication? How many way I have to deliver my data?
Unicast,
Yes, unicast,
broadcast.
multicast, and broadcast. What is the meaning of unicast?
It's only receiver.
If there is only one sender and one receiver, right? One to one communication. Multicast,
One to many.
if there is one sender and multiple receiver. And broadcast,
One to all.
one to all in a network. One to all in a network. No, like, you know, if I am speaking right now, right, what I am doing, I am doing broadcast, right? But this broadcast is not for everyone in the world, right? This broadcast is for those people who are in my network, correct? My network is what? Through Google Meet, I have created one network. Getting my point? You guys have IP address in the same subnet, maybe it can be in different subnet also. Don't worry, we will discuss that. But you guys are in my network, in my classroom, so that's why you are receiving it, right? So broadcast means not like one to all in a network. Fine. Then modes of communication: simplex, duplex, and then sorry, simplex, half duplex, half duplex and full duplex. What is simplex?
The device can only send or receive it.
A device can either send the data or can either receive the data, right? A machine can only send the data or it can receive the data. A sender device, you can say, a sender device can only send the data and receiver device can only receive the data. Half duplex, a sender can send the data as well as receive the data. In the same way, a receiver can send the data as well as receive the data, but not at the same instant of time. Not at the same time. At a time, either it can receive or it can transmit. Then full duplex. Bidirectional communication. Simplex is unidirectional. Half duplex is also what? Bidirectional, but not at the time. And this is full duplex is bidirectional at a time. Then guys, what we discussed after modes of communication? Devices. Okay, we have covered only these devices and one more thing, that is NIC, right? We discussed about NIC as well. What is NIC, guys?
Is a network interface card.
Very good, network interface card. Network interface card.
It will use a device to identify.
It is used to connect a networking device to network. Yeah, it is used to connect a networking device to network, you can say in simple word. It is used to connect. Through NIC only you can connect your laptop to a network. NIC can be wired and wireless. We also seen how it's look like. A device can have multiple NICs. Now guys, next device is what? Hub. Hub. So what is switch? Switch is used to connect multiple devices together. Hub is also used to connect multiple devices together only. But the difference is what? Hub can only do broadcast and switch can do all types of communication. Unicast, multicast and broadcast. So which device you will use for your company to connect multiple devices together? Switch. Because in hub guys, we don't have privacy. Two users cannot communicate with each other in secure way. Everyone will receive their data. Okay, so see guys how hub look likes. This is what? Switching hub. Through this hub you can connect how many devices? You can connect how many devices guys through this device? How many computers? 5 only. Right?
I have one question.
Yeah.
Do we still use hub in any?
Right now, brother, you know, right now also I am using it. Right now. Why? Again, actually I have 3 computers. And do you think I need to purchase switch to connect these 3 computers together, because switch is going to cost me around 40,000 and cost of hub is only 4 to 5,000. So it's totally depends on your requirement. Still you can use if you have 2 computers or 3 computers.
Yeah. But when we buy this kind of small device, we always call this switch. But how do we know if it is a switch or hub?
No, what I am saying, hub can be not used in the corporate, right? In the enterprises network, you are not going to use hub, but for your personal uses, right? Or for, in a small shop, they guys are using it. So here what you can do, you can connect 5 computers together. So let's say you have 5 computer here, computer 1, 2, 3, 4 and 5. And let's say not 5, one is here router, and my hub is connected with one, let's say router. And then this router is connected with one, let's say what, ISP. Like this. Now can these 4 user access internet? Yes.
Yes.
But what is problem? See, first problem over here is what? This machine is A, this machine is B, this machine is C, this machine is D, this is router. Whenever let's say A want to communicate with D, first A should have source IP address, A should have destination IP address, means IP address of computer D. Computer A should have source MAC address, their own MAC address, and computer should have destination MAC address. These are 4 requirements of communication. If 2 devices want to communicate with each other, both devices should have what? Source IP, destination IP, source MAC and destination MAC. And whenever a device, let's suppose IP address of this device is 10.1.1.1, IP address of this device is 10.1.1.2, IP address of this device is 10.1.1.3, IP address of this device is 10.1.1.4, and IP address of router is, let's say, 10.1.1.254. Just assume. Now who is going to tell what is the destination IP address? Like if computer A want to communicate with computer D, right? Let's say computer A want to send hi on WhatsApp to computer D, right? So computer A need what? Destination IP address of destination machine. And who will tell destination IP address of this machine? You. Like if you are accessing Google server, you are typing in the browser www.google.com. That means what? That means you are telling IP address to your machine. You are telling IP address to your machine. In the same way, if PC A want to communicate with PC D, you have to tell destination IP address of machine. But guys, question is, and biggest question is what? Who is going to tell the MAC address of destination device to this machine? That is fine, Praful. I am writing www.google.com in the browser, or I am first going to the profile of a particular user or to my friend. Like if you are sending hi on WhatsApp to me, first you have to open my profile in the WhatsApp. So what you are doing, actually you are telling the IP address of my device to your machine. And after that, if you are typing hi, so that hi will come to me, to my device. Okay, that is fine, Praful. I am agree that we will provide destination IP address, but who will provide the destination MAC address? Correct? So guys, to store MAC address, all networking devices maintain a table. That table is called ARP table. That table is called ARP table. And whenever you will configure a IP address on machine, let's say on PC A, I have just configured this IP address 10.1.1.1. I've told to PC 1, brother, your IP address is this one, take it. Once you will configure it, this device will create one table. That table is what? ARP table, ARP table. And in this table, it is going to make one entry that my IP address is 10.1.1.1 and my MAC address is A. So whenever you will ping to PC D, or whenever you will send some data to PC D, you will tell the destination IP address. Then computer A will check ARP table. Brother, what is the MAC address of 10.1.1.4? Because you have told to PC 1, ping to 10.1.1.4. So PC 1 will look up their ARP table first. Let me check what is the MAC address of 10.1.1.4. Is there any entry, guys, in ARP table? No. PC 1 will came to know, oh my god, I don't have MAC address of destination device. Let me do one thing. There is one protocol on device. That protocol is again ARP protocol. And ARP protocol is responsible to resolve MAC address from IP address. computer A have destination IP address, but they don't have destination MAC address. So PC1 is going to call ARP protocol. Hey ARP, come here and please find me what is the MAC address of 10.1.1.4. Then ARP protocol will generate a broadcast message from here, right? Why broadcast? Because this machine don't know who is computer D, the machine whose MAC address is D, or this computer you can say don't know what is the MAC address of 10.1.1.4. So it will forward this broadcast message to everyone in the network, and only that computer will generate reply who is using this IP address. Because in the broadcast packet, source IP will be what? 10.1.1.1, destination IP will be what? 10.1.1.4, source MAC will be what? A, destination MAC will be what? Don't know. So let's do broadcast. Getting my point? Getting my point, guys?
That is called ARP request.
That is called ARP request. We will discuss ARP protocol, don't worry. We are not talking about the ARP, just I am making you familiar with this device and switch, hub and switch. Try to understand the process. What process will happen over here when PC A will ping to PC D? So it will do broadcast. That means hub should receive it on this interface and it will forward one copy from here, one copy from here, one copy from here, and only computer D will generate reply, that is ARP reply. And in the ARP reply it is going to share their MAC address. Brother, my MAC address is D, my IP address is 10.1.1.4. Once PC A will receive the ARP reply message, it will make one entry in their table. Oh, 10.1.1.4 is one IP address whose MAC address is what? D. Now PC1 have source MAC as well as destination MAC. So this time PC1 will try to do unicast. Getting my point? Because this time PC have source IP, destination IP, source MAC, destination IP. So now it will try to communicate with PCD only, right? It will not forward traffic to D, C and B. So it will generate a unicast message where source is going to be what? 10.1, destination is going to be what? 10.4, source MAC is going to what? A, destination MAC is going to be what? D. It will forward to hub. But you know, hub don't have memory. Here we don't have memory. This is, you know, what is hub? Hub is like electric board. Let's say you need to charge 4 mobiles together, and in your plug, in your board, there is only one slot. So what you can do, brother, tell me, if you want to charge 4 phones together and you have only one slot in the board, what you can do? You can purchase one extension board from the market, right? Like this.
Yes.
And all ports will be connected together through wire. Getting my point? Then you can connect this extension board to your single slot, and now you can charge 4 phones. Under this extension board, what is happening? All ports are connected together. In the same way, in the hub also, all ports are directly connected with each other inside. Like there is one cable, right? All ports are connected with that cable. That's it. There is nothing in the box, inside the box. So hub is not going to read this data. This data is coming from where, this data is going where, doesn't matter. If I have received one data on this packet, this interface, so I will forward it from my all interface except receiving interface. So it will forward one copy to PCB also, one copy to PCC also, and one copy to PCD also. 1 second, guys. Any question till here? Any question? Any question? Are you getting my point? Okay, let's move. So hub don't have capability to do unicast. If this box will try to do unicast, what this device need to do? This device should first read the data, means traffic, you can say frame, right? It should check what is the source, and it should maintain one table. It should make one entry in their table that on this port, let's say this is port number 1, this is port number 2, this is port 3, this is port 4, it should maintain one table, and the table it should make entry like this. I am receiving a traffic on port number 1 where source is what, A. That means on this particular interface device is connected whose MAC address is what, A. If I am receiving a traffic on my port and in that traffic source is A, that means which device is connected with this port? Device whose MAC address is A. Correct, guys? So it will make, it should make one entry like on port number 1 a device is connected whose MAC address is what, A. Then it should check destination MAC. So destination MAC is what, D. So it should check again the table. Is there any port available for D MAC address? No. Then let me do broadcast. Let me ask to everyone whose MAC address is D. Then PC will generate reply. In the reply, source MAC will be what, D. Destination MAC will be what, A. Correct? It will forward to this box. Again this box is receiving a frame on their interface. On which interface? On interface 4. So it is going to make one entry in their table. Okay, on port number 4 a device is connected whose MAC address is nothing but D. Then this box should check again what destination. So destination is A. Again it should check this table. Yes, there is one entry for A MAC address. Port number is 1. Oh, a device whose MAC address is A is connected with which interface? Port number 1, with port number 1. So it will forward the packet from port number 1 only. And this is what, guys? Unicast. Now this time when PC1 is going to forward data to PC-D again source MAC A, destination MAC D. It will forward the traffic to this box. This box will update this entry, source MAC address it will learn again. Then it will check the destination MAC. Destination MAC is D. Oh, port number is 4. Let me forward it from this interface only. So see how this box is not doing what? Unicast. And this is how switch work. This is working off what? Switch. Switch is going to maintain a table. That table is called MAC address table. MAC address table. And always keep in mind, whenever switch will receive a traffic on their interface, first it will learn the MAC address of that packet, that traffic. It will came to know the device who is connected with this interface is using this MAC address, right? So whenever I will receive a traffic for this MAC address, I will forward that traffic from this interface only. Yes or no? Yes or no? Clear?
Yes.
Yeah. So this is what, guys, switch. And this is the advantage of switch. This is the reason why we are using switch. And on the switch you will get more ports as well. More number of ports. On hub you will get few number of ports only. Other advantage. Now how this MAC address table is going to work, how switch is going to build this MAC address, right? What extra information will be there? Like there will be VLAN information also. What will be the timing? Like for what time switch is going to maintain this table? For how long time this PC is going to maintain ARP table? So a window machine is going to maintain ARP table for 4 hours. After 4 hours it will remove the entry. Like within 4 hours, if this PC will not receive any traffic from D MAC address, it will remove this entry. And switch is maintaining their MAC address table for 300 seconds by default. Again, you can change it. You can change it, and we will change it, right, while configuring. So we will understand these things, guys, in the switching. So now hope hub and switch both devices is clear to you. If yes, then let me know. I will move to router. And if you want to see how switch looks like, yes.
Actually, I just want to ask, like the ARP, you said this table is when it is made, it is stored in the box like PC or in the switch.
No, I didn't get you. Can you repeat your question?
Like you said the table is made, ARP table is made
By PC.
Yeah, so it is stored in the PC for 4 hours, right?
Right.
Okay. So that's it. I just want to confirm that.
Yeah. PC is going to window operating system, not PC. You can say. You can check what is the ARP table in Mac operating system, in Linux operating system. You can Google it. What is ARP table time, you can say ARP table time in Linux. What is time, right? You can check it in what, Mac OS, what, 2 minutes, and you can check in window somewhere it's saying 2 minutes, 20 minutes, but in window operating system it is going to maintain for 4 hours. This is, I think, for a specific windows, maybe this output.
Okay, sir.
Okay, so again, this is not important for you, like what is Mac table timeout on the device. You don't need to learn it. What you will do with this? Yes or no? Just you need to run the ARP table. You can check the PC is learning MAC address of destination device or not. Let's say if you are troubleshooting a network, your PC is not able to access a particular server, right? So first step is what? First step is you should check the ARP table that this PC have destination MAC address or not. Yes or no? This machine is able to resolve ARP or not? Yes. Someone has raised hand. Yes, ask me guys. Ask me question. Danny. Yes, Danny.
Yeah, I just wanted to know, is there like a notepad somewhere? Because like all the stuff you wrote, I was following, but then it's like sometimes I look back and it's like maybe the thickness of the pencil is, I don't know, like sometimes I look back and it's like I missed something, but then I feel like I understood everything you said, but it would still be nice to like have that reference. So maybe if you can use like a notepad so that like after the class you can share with us somewhere. Because I feel like I understand it, but then like if you can still have that kind of thing you're writing down, like a side note to it. So, like if you ask me to reproduce all that you said, I would think I understand, but somehow it's like I'm gonna miss something, you know what I'm saying? So maybe if we can have like a notepad, or maybe as you say, you type it, something like that. Because like if we
I have already shared notepad with you, right? Oh, after the class, what you can do, you can call me or you can watch day one video, brother. In there, I have discussed, the notepad, how you can use study materials.
okay, so you share the classmates with us.
Correct. And here everything is mentioned, right? Like if you will read this note, like you can see in this note, what I have written here. Switch always learns source MAC address from the data, and on the basis of destination MAC address, switch will take forwarding decision, right? There is topology as well, like if PC1, PCA, PC1 want to communicate with PCB, right? Source MAC will be A, destination MAC will be what, B. And where it is going to store the entry in the ARP table. Switch is going to maintain what table? MAC address table. So when switch will receive this frame over here on this interface, let's say this is 1, it is going to learn what? Source MAC address, means A. MAC address is connected on which interface? Port number 1, like this. There's some diagram as well, and you can read more about it. I can identify you by using your name or by using your address. In the same way, name can be used by multiple people. Okay, we will discuss this point, don't worry, right? After that it will be easy for you. For now you can read switch here. Switch are used to connect multiple devices in LAN network. Switch works on full duplex. Switch can be unicast, multicast, and broadcast. So this is what I have discussed, that how switch can perform unicast. That's it. And everything is there. There are one more notes. Okay, so you can read this one as well. Switch is an intelligent device, means switch have memory. If switch is maintaining a table, guys, or creating a table, that means what? Device has memory. So if device has memory, then we can give instruction to the device. And how you can give instruction? By running command. By running command. Like on PC, if you want to create VLAN, so you have to run one command. Through that command, you can tell to switch, please create one VLAN, like that. What you can say, please do one lab on it. You can say this, right, to understand better. So see, this is my packet tracer, guys. If you guys are not familiar with packet tracer, so when you will install it, you will get this interface, right? When you will open the software, you will get this interface. Now in the bottom you can see there are some router devices, like these are routers, different series routers. Then you have some switches, these are switches. So let me take one switch over here. See, in packet tracer how switch looks like. In the real time, see how switch looks like. These are switches, right? So you can see this is 24 ports switch. So you can connect how many devices? 24 computers. I think 24 ports are there, right? In packet tracer, this is how switch looks like. Now if you want to connect few computers here, so you can click on N devices. In the bottom you can say N devices, right? If you will click over here, you can get lots of N devices like PC, laptop, servers, printer, IP phone, voice over IP device, phone, TV, tablet, smartphone, right? So like this I can use a smartphone. Let's say I have some PCs, so let me use some PCs over here. So simply I can drag and drop. Let me delete it, smartphone for now. Now if I want to connect these all devices together, what we need? Cable. So let me use cable over here, like this. I can select cable, and see there are multiple cables, so we will discuss these cable types. For now I am using automatic, right? If you will choose this one, first one, it will automatically choose which cable will be used between switch and PC. If you are connecting a switch and router, it will sense what type of cable I should use, right? So here it will sense automatically. Like this we can connect multiple computers here. And now guys, on PC, if I will check ARP table, see how you can check ARP table on PC. Simply in the command prompt you can run this command, ARP minus A. See what it's saying, no ARP entries found. So there is no any entry in ARP table, yes or no? So now I am going to configure one IP here. Let's say 10.1.1.1. Subnet mask is, let's say, 255.255.255.0. Correct? Now again, there is no any entry. So you know, in Windows operating system, machine is not going to store their own IP address and on MAC address. So that's why here you are not able to see any entry. In the same way, on other PC, on this PC also I am going to configure. See, I have configured IP address over here, so it will generate one gracious ARP to check duplicate IP address, that my IP address is duplicate or not. These are the initial steps, that whenever we will configure IP on a device, first of all my device will check the duplicacy, that this IP address is duplicate or not. For that, my device will generate a broadcast message, and it will forward that broadcast message to whom? To switch. And switch, when switch will receive the broadcast message on this interface, switch will learn what? Source MAC address. So you can see what is the MAC address of this machine, PC. What is the MAC address of this PC? What is MAC address, guys? This one. In the last, put the digit 4839. And now if you will check the MAC address table of switch, you can see here. So MAC address table. Is there any entry? There is no entry. But I think there should be one entry because of gracious ARP. But let me do one thing. From here, from PC 0, I am going to generate some traffic. I'm going to ping any random IP address, this is 10.1.1.100, right? It will forward traffic to switch, and on switch will receive the traffic, it will learn source MAC address. Now you can see there is one entry in MAC address table. Correct? This is MAC address of PC 0. 4839. This is MAC address of PC. You can see here. Getting my point, guys? So switch have learned MAC address of PC0 on which interface? On 0/1 interface. You can see this interface. So now whenever switch will receive any traffic where destination is going to be this one, switch will out that traffic from F0/1 interface, right? And in the topology also you can see interface. This is 0/1 interface, correct? Right?
Okay, so this is the table you're talking about, right?
Yeah, this is MAC address table. Yes, this is the table which I am talking about. You know that switch is going to maintain for unicast, for unicasting.
So mark at this table is the same as ARP table.
No, ARP table is used to store what? So IP address and MAC address, and MAC address table is used to store what? MAC address and interface port. Getting my point? In the ARP table, you will get what? IP address and MAC address. Let me do one thing. Let me configure IP on PC1 also. On PC1, I am going to define 10.1.1.2. Subnet mask 255.255.255.0. Now PC0 and PC1, these two devices can communicate with each other. So let me do one thing. Let me ping. Let me ping PC2 from PC1. Ping 10.1.1.2. See, ping is working. Yes, I am getting reply. That means ping is working. Now if you will check ARP table, ARP minus A, you can see the ARP table. What is the entry there? IP address and MAC address. If you will see the MAC address table, so MAC address table, what is the entry? MAC address and port, right? Now if you will check the table, see there are two entry. One MAC address is on port number 0/2 and one MAC address is on port number 0/1, right? So when you will tell destination IP address to PC number 0, getting my point? Like when I am typing command ping 10.1.1.2, PC0 will get to know this is what? Destination IP address, right? Now PC0 need MAC address also. So it is going to check their ARP table, ARP table. So yes, there is one entry. MAC address of 10.1.1.2 is this one. So now it is going to put source IP, destination IP, source MAC, destination MAC in the packet. Source MAC will be what? MAC address of PC0. Destination MAC will be what? MAC address of PC1. Then it will forward to switch. Switch will check their MAC address table to know what is the exit interface for PC1, right? For that, switch is going to check what? First of all, definitely switch will learn MAC address, source MAC address on this interface. Whenever switch is going to receive frame, this is guys default behavior of switch. Whenever it is going to receive a frame on their interface, it will blindly learn source MAC address. It will make entry in their table. In which table? MAC address table. So that's why in MAC address table you are able to see there are two entry. It have learned one MAC address on 0/1 interface and one MAC address on 0/2 interface, right? So it is going to update this entry where it will receive a frame. Then it will check destination MAC. So destination MAC in packet is what? PC1. It will check, is there any entry for this MAC address? Because this will be the destination MAC address in the packet, right? So yes, there is one entry, and exit interface is 0/2. So this switch is going to forward traffic from 0/2 interface from this interface, not from this interface, right? So this is what? Unicast. So when a PC don't know the destination MAC address and PC have knowledge about the destination IP address, it will check ARP table. Whenever switch need to forward the traffic and it need exit interface, right? From which interface I need to forward the traffic, then it will check what? MAC address table. This is difference between ARP table and MAC address table. Is it clear now?
Can you repeat that, please?
Yes. Can I repeat? Should I repeat? Should I repeat, guys? What I'm saying, ARP table is used to find destination MAC address. If a PC is not able to find destination MAC address in their ARP table, it is going to call ARP protocol. Again, that is secondary thing, we will discuss that. right? For now, just understand ARP table and MAC address table. So PC maintain ARP table to find the destination MAC address, and switch maintain MAC address table to perform unicasting. Unicasting, like how I can find the exit interface. What is the exit interface for destination MAC? Let's say MAC address of PC0 is A, MAC address of PC1 is B. IP address of this PC is 10.1.1.1, IP address of this PC is 10.1.1.2. When PC1 is going to communicate with PC2, it will generate one data. In the data, there will be source IP address 10.1.1.1, destination IP address 10.1.1.2, source MAC address A, destination MAC address. Let me check my ARP table, right? So in the ARP table, if there is entry like MAC address of 10.1.1.2 is B, it will take destination MAC address from ARP table and it will put over here. Destination MAC is what? B. And then it will forward to switch. Switch will receive it on 0/1 interface. First of all, it is going to learn source MAC address. It will make one entry in their table. Brother, I am receiving one traffic on 0/1 interface and source MAC address is A. That means the device which is connected with this interface is using A MAC address. Then switch is going to check destination MAC address. Destination MAC address is B. It will check their MAC address table. If entry is there, it will pick destination. It will out the traffic from that interface. If there is no entry, it will do broadcast. So switch is also doing broadcast, but first time only, not second time. Switch will also do broadcast first time. When switch will do broadcast, guys? When traffic is broadcast. Let's say a switch is receiving a broadcast traffic, then definitely switch will perform broadcast. The second scenario, when switch is going to perform broadcast, when switch don't know the exit interface for destination MAC address. Second scenario is when switch don't know the destination MAC address, or exit interface for destination MAC address. In these two scenarios, switch is going to do what? Broadcast. But let's say entry is there in the MAC address table that on 0/2 port a device is connected to whose MAC address is what? B. So now switch have entry in the MAC address table, and in the packet, in the traffic, destination MAC is also B. So it will out the traffic from what? 0/2 interface, from this interface. So this is what unicasting. Is it clear now? Right. And same thing is happening over here. Like on PC number 2 also, I'm going to configure one IP, that is, let's say 10.1.1.3, submit mask 255.255.255.0. That's it. Now from PC0 also, I'm going to ping PC1 and PC2. Ping 10.1.1.1, and before pinging 10.1.1.1, if you will check ARP table, there is no any entry, right? Now when you will ping 10.1.1.1, right? So see, entry is not there. So first my devices have generated what? ARP request message to find the MAC address of 10.1.1.1. Once it will receive ARP reply message, it will make one entry in their ARP table, in this table again. And now you can see there is one entry. What is MAC address of 10.1.1.1? This one. So now this PC have destination MAC address. So now this PC is going to send this first packet. This is first packet. Before destination MAC, this PC cannot send any traffic, right? So again, in the same way, now this PC have what? MAC address of 10.1.1. If I will ping to 10.1.1.2, 10.1.1.2, this time again first it will generate ARP request message. It will get ARP reply. It will learn the MAC address of 10.1.1.2. It will make entry in the ARP table, and then it is going to forward traffic, the first traffic, to 10.1.1.2. And at the same time, you can check the switch MAC address table also. Like switch is also learning MAC address. You can see now switch have learned MAC address on their all interfaces, like on 0/1 also, 2 also, and 3 also. Getting my point? Is it clear? Any question? Don't worry about the ARP protocol, guys, because in the packet flow we will discuss ARP protocol and ICMP protocol in very detail. So don't worry about the ARP protocol. Just basic function of switch is clear to you or not? Like how switch can do unicast, how switch is better than hub. This is my topic right now. How switch is better than hub? Why switch is better than hub? Because it can perform unicast, multicast as well as broadcast, but hub can only do broadcast. Because guys, you know, if this is not switch, this is hub, and MAC address of this machine is A, B, C, correct? Now PC A want to communicate with PC C. It will generate a data, source will be A, destination will be what? C. It will forward to hub. Hub is going to do what? Broadcast, means it will forward one copy to this machine also, one copy to this machine also. Guys, in the data, source MAC is A, destination MAC is C. When PC1 will receive this data, this traffic, what this PC will do? This PC have to check the destination MAC address. What is destination MAC address? So destination MAC address is C and PC MAC address is B. Oh, this packet is not for me. PC1 will think this packet is not for me. So PC1 will do what? PC1 will discard this. PC1 is going to discard it, right? So if you're thinking that, okay, if PC is discarding and that, what is problem, Praful? What is problem here? Brother, try to understand. If this PC is even checking what is the destination MAC address, if this PC is processing the data, that means this PC is using their CPU utilization. It is using their CPU. And just assume this is not a PC, this is a server. And lots of outside user means this hub is connected with one what? Router, and this router is connected with ISP, and there are lots of user outside. They are accessing this server every day, right? Multiple times. So just assume if this server will receive lots of broadcast messages with different destination MAC address, right? That means that traffic is not for this server. But every time server have to process the data, right? It can increase the CPU utilization of this server, right? And once CPU utilization of a device will reach to 80%, above 80%, or even above 75%, right? Your device will start getting hang. Maybe a genuine user cannot access the actual services which are available on the server. Getting my point? So this is problem with broadcast, that every time we should not forward unwanted traffic to devices like PC, like server, like switch, like routers. If these devices will get dummy frame, lots of dummy frame, right? It is unnecessary processing those data. That means my devices are using their CPU utilization unnecessary. Because whenever a PC or any device will receive a data, let's say this is router, this router is receiving a traffic on this interface, this is interface number 1. First thing that this router will do is what? It will check what is the destination MAC address in the packet. If destination MAC address is matching with my interface, then only I will accept it, otherwise I will discard it. If destination MAC address will match, then only it will check next information, like what is destination IP address. Again, if destination IP address will match, then only it will accept it, otherwise it will discard it. If destination IP will match, then only it is going to check next information, like what is the port number and what is the actual message. First of all, our interface is going to check what? Destination MAC. Getting my point? So this is problem with hub, and this is the reason why we are not using it nowadays. Clear? Cost of this switch is, this is guys older switch, very old, and this one is second hand, not first hand, refurnished, and cost is what? Around 13,000. So these devices are costly. Okay, so now guys, next device is what? Router. So what is the use of router? Router is used to connect multiple networks together, correct? So let's say here in my scenario, now I have two network. One switch is here, and then we have lots of end devices like PCs and servers. Then I have one more switch here, Again, we have lots of end devices here, PCs and let's say server. Now I need to connect these two network together. What I can do, I can use a router over here. Second scenario can be what? That there is not this network, right? There is ISP and I want to connect this network and ISP network together. Again, we need what? Router. Okay, like this we can connect these two network together. This is what? Router. Now again, you know how router is going to receive the traffic. See, router will again maintain what? ARP table. Router is also going to maintain ARP table. Whenever router will receive a traffic on their interface, it is going to make what? ARP table. Maybe command will be different to check ARP table of router and ARP table of Windows PC. But both devices are going to maintain ARP table, right? If router also need to forward a traffic to a destination, to a particular destination, let's say from the router I'm pinging 10.1.1.1. So router also need what? Destination IP, destination MAC address of IP address. Correct, guys? So router is also going to maintain ARP table. The second thing, that whenever you will configure IP on this interface, brother, can you keep your mic switch off and switch on only when you are? Yes, correct. Guys, if you are not speaking, keep yourself on mute. Otherwise, I'm getting noise. Okay, so router is also going to maintain ARP table. The next table that router is going to maintain, and the very important table of router, is known as routing table. Like switch uses what? MAC address table to forward traffic. MAC address table to forward traffic to perform unicast communication. In the same way, router is going to use routing table to forward the traffic. Which table? Routing table. And you know how router is going to build routing table? Also, will configure IP address on interface. Let's say this is interface 1, this is interface 2. Here I am defining one IP 10.1.1.10/24. Subnet mask 255.255.255.0. If you don't know IP address, don't worry. So once I will assign this IP address on this interface, router is going to calculate the network ID of this IP address first, and then it is going to make one entry in the routing table, right? So network ID of this IP address will be 10.1.1.0, right? We will understand in subnetting how. So router is going to make one entry in their table that this network is running on which interface, guys? One interface, interface number 1. When I will assign IP on this interface, that is 20.1.1.1/24, again it is going to calculate network ID of this IP address and it will make one entry in their table that 20.1.1.0/24 network is connected on which interface? 2. This is what? Routing table of router. Now if router will receive a traffic where let's say destination is 10.1.1.1, right? So when router will receive the traffic, it is going to check the destination IP address. Destination IP address is what? 10.1.1.1. It is going to check the routing table. What is the exit interface for 10.1.1.1? And guys, this IP address comes under this network, right? So router will came to know that, okay, my interface number 1 is going to be odd interface for this network for the destination IP address. So this is how router is going to forward traffic from this interface from port number 1. If router is receiving a traffic or destination is 20.1.1.1, again it is going to compare destination IP address with routing table. Is there any entry available? If entry is not there, then router will discard it, drop it. If entry is there, it will find what is the exit interface, from which interface I need to order the traffic. So see, 20 network is connected on port number 2, so it will order the traffic from port number 2. This is basic function of router. Clear? And see how routers look like. These are what? Routers. This is what, guys, router. This diagram has,
Less switches, less switch port. Sorry.
yeah, router have less ports, very less ports. Like router is not used to connect multiple networking devices, na brother. It is used to connect multiple network, right? So network means it is connecting multiple devices, right? Like lots of networking devices through one port.
Yes.
So see guys, on this router, how many interfaces we have? What happened? How many interfaces we have? I'm talking about
Four.
4 ports. Here you are able to see 4 ports, right? And this is what? Power port. On this port you will give power. There is on off a button. And there is slot as well. Like if you want to add more ports, you can add here, right in the slot. Okay. And let's say here, these 2 ports are what? LAN port. And these 2 ports are what? WAN port. So how I will use this router? Let's say I have one switch here, and then there are lots of computers. So I can connect this switch with this port. Again, I have one switch. That switch have lots of computers. So I can connect this switch with this port. And now I want to connect these 2 network to internet. So there is internet. I can connect one link from internet to what? Internet router to my WAN port. Getting my point? Now I need to configure public IP address on this interface, one IP address on this interface, one IP address on this interface. Getting my point? Okay, okay. Okay, guys. LAN port, WAN port. I can connect 2 ISP over here for the backup purpose. Let's say if ISP1 will goes down, still I have connectivity from ISP2. Right? Let's say this is ISP1, this is ISP2, and here I have my switches. And then switches are connected with computers like this. I will configure the router in such a way so that whenever ISP1 will goes down, it will sense it and it will start shifting all traffic towards ISP2. When again ISP1 will come up, it will start shifting all traffic from ISP2 to ISP1 towards ISP1, right? So we have to configure the router. We have to give instruction to router, right? So with the help of configuration, you can tell your router that how you need to behave, right? But guys, basic function of router is what? To connect multiple networks together and to forward traffic. To perform unicast, it is maintaining a table. That table is called routing table. And by default, router store their directly connected network in their routing table. By default, routers store their directly connected network in routing table. So let's say I have one router here, R1, with let's say 4 interfaces. Let's say this is 0/0 interface, this is 0/1 interface, this is 0/2 interface, this is 0/3 interface. If I'm saying 0/0 means what? Means I'm talking about the port. Which port? See, this is let's say my router. On the router there are let's say 2 slots. In first slot there are 2 ports. In the second slot also there are 2 ports. This is slot number. Slot number of this slot is what? 1, or you can say what? 0. Slot number 0 and slot number 1. This is port number 0, this is port number 1, this is port number 0, this is port number 1 in this slot. So what will be interface ID of this port? 0/0 means slot number 0, port number 0. What will be interface ID of this interface? 0/1 means slot number 0 and port number 1. What will be the interface ID of this port? 1/0 means slot number 1 and port number 0. What will be the interface ID of this interface? 1/1 slot number 1 port number 0. Getting my point, right? So this is what, this is slot number, this is what port number. So let's say here I am running one IP that is 10.1.1.1. Here I am running one IP 10.1, sorry, not 10. I have to configure different network. Let's say 20.1.1.1. Here I am running IP 30.1.1.1. Here I am running IP 40.1.1.1. So can anyone tell me, guys, how routing table of routers will look like? Like how many entry will be there in the routing table of this router? Yeah, we will have 4 entries, right? For on each interfaces, router is going to calculate what network ID. So what will be the network ID of this IP address? 10.1.1.0. Don't worry, we are going to discuss in IPv4 addressing. Network ID of this IP address will be what? 20.1.1.0. Network ID of this IP address is going to be what? 30.1.1.0. Network ID of this IP address is going to be what? 40.1.1.0. So router is going to maintain their routing table like this. It will make one entry like 10.1.1.0 network is connected on which interface? 0/0 interface. 20.1.1.0 network is connected on which interface? 0/1 interface. 30.1. Not yes, 0/0 on 0/1 10 network is connected. No, let me correct it. On 0/1 interface, on this interface 10 network is connected, right? On 0/0 interface 20 network is connected. 30.1.1.0 on which interface this network is connected? 0/3. 40.1.1.0/24 or 0 is connected on which interface? 0/2. Getting my point? This is routing table of router. Now if router is receiving a traffic where destination is 10.1.1.1, any IP address from this network, it is going to forward that traffic from this interface. If router is receiving a traffic where destination is 20.1.1.1 from this network, it is going to forward that traffic from 0/0 interface. If router is receiving a traffic where destination is 40.1.1.1, right? So this IP address comes under 40 network. It will check what is the exit interface 0/2. It will forward that traffic from this interface. If router is receiving a traffic where destination is 30.1.1.1, it will forward that traffic from which interface, guys? Tell me, this is question. Router is receiving a traffic where destination IP address is 30.1.1.1. From which interface it will forward the traffic? Tell me, guys. Come on. Destination. A router is receiving a traffic where destination IP address is 30.1.1.1. Router will forward the traffic from which interface? Means router will out from which interface? Out the traffic from which interface? 0/3. Correct. Because router is going to check their routing table, and in their routing table there is one entry for 30 network. 30.1.1.1 is the IP address belongs to 30 network. And for 30 network, exit interface is what? 0/3. Means 30 network is connected on 0/3. So I will forward traffic from 0/3 only. And maybe from 0/3 there is one switch, and that switch is connected with one PC whose IP address is what? 30.1.1.1, right? So router will forward traffic from this interface. Switch will receive it on this interface 0/1, let's say. Then switch is going to forward it to PC like this. Switch will check which table? MAC address table. MAC address table. So router is checking what table to forward traffic? Routing table. Switch is going to check what table to forward the traffic? MAC address table. And guys, for this entry there is no any timer. Yes, Desai.
Yeah, principally. So you say that so really from the ISP, right? The router makes a request, and then the router gets the information from the ISP, into the 30 IP address, and then Like, how does the switch come in together? I don't understand that part.
No, don't worry.
It's kind of
That we will discuss. That we will discuss. Don't worry. For now, just understand how router is working, like what table router is maintaining and how it is going to make entry in their table. That's it. Now you know router is, if you will check the routing table of a router in real time, you will get thousand number of routes, thousand number of entries, but that router will have only 3 to 4 physical interfaces. So here we are also going to inject routes under the routing table, and that is the actual work of network engineer. You are going to add some routes over here. Let's say because I have one router here, R1, then R2, correct? Here I have one switch, and here also I have one switch. Here I have one PC, here I have one PC, correct? IP address of this interface is, let's say, 20.1. IP address of PC is, let's say, 20.10. IP address of this PC is 10.10, and IP address of this interface is, let's say, 10.1. IP address over here is 12.1. IP address over here is, let's say, 12.2. Anything. Now can you tell me the routing table of R1, guys? In the R1 routing table, how many entry will be there?
2.
2 entry. One on 0/0 interface. Which network? 10.1.1.0. One on 0 slash, sorry, this network is on 0/0 interface, right?
Yes.
On 0/1, which network? 12.1.1.0. In the routing table of R2, again there will be 2 entry, one 20.1.1.0, or you can say what? On 0/0, 0/0, 0/1. On 0/0 interface, one network is running, that is 20.1.1.0. On 0/1 interface, one network is running, that is 12.1.1.0. Now when this PC want to communicate with this PC, source IP will be what? 10.10, and destination IP will be what? 20.10. Yes or no? Yes or no, brother? This PC will forward it to switch, switch will forward it to router. Now router will check what destination IP address. What is destination IP address? 20.1.1.10. Router is going to compare destination IP address in their routing table. Is there any entry available for 20 network? Is there any entry available for 20 network in the routing table of router 1? No, guys. There are only 2 entry, right? So this time router 1 is going to drop the traffic, because router 1 don't know what is the exit interface for this network. Router is saying I don't know where is 20 network, so I am going to discard the traffic. It will discard it. So if you want to make communication between these two computers together, right, what you need to do, you have to tell to router 1, brother, whenever you need to forward traffic to 20 network, please forward that traffic from this interface, from 0/1 interface. So this is manual work of network engineer. Manually you have to inject one route here in the routing table of R1. You have to make one entry like this. On 0/1 interface, one more network is connected, that is 20.1.1.0. Getting my point? In the same on router number 2, you have to inject one route in the routing table of router 2. Like on 0/1 interface, one more network is connected, that is 10.1.1.0. So again you have two options. Either you can inject this route manually on both router, or you can configure a process on router. According to that process, router itself is going to exchange the routes, and those process are routing protocol. Those process are routing protocols. Means we can configure routing protocol here. Routing protocol like RIP, EIGRP, OSPF, BGP, ISIS. I can configure OSPF on router number 1, OSPF on router number 2. Then router 1 will tell to router number 2, brother, I have one network that is 10.0.0.0. Please make one entry in their routing table for 2010 network. And whenever you need to forward traffic to 10 network, please forward that traffic to me. In the same way, router 2 is going to tell to router 1, brother, take my 20 network, make it entry in your routing table. Whenever you need to forward traffic in 20 network, forward traffic to me. Getting my point? So we have two options to inject routes, but by default router maintain what? routes in their routing table, only directly connected network, right? By default, router maintain only directly connected network in their routing table. So like in packet tracer, guys, if I will use one more switch over here, let's say this is my network. What is the IP address of PC0? 10.1.1.1. What is the IP address of PC1? 10.1.1.2. What is the IP address of PC2? 10.1.1.3. Like this, let's say I have one more network. I have again some more computers here. Again, I have one switch here. For now, guys, you will use this switch 2950 switch, or you can use 2930 switch, this one, right? You can use any one from last two. And let me connect these switches together. Let's say IP address of PC3 is what? 20.1.1.1. IP address of this PC is what? 20.1.1.2. And IP address of this PC is what? 20.1.1.3. Getting my point? Now, if you want to connect these two networks together, what you need? A centralized device. That device is known as router. So for the lab purpose, guys, always use this router 2811. This router support multiple commands. Now I need to connect these two networks together through these routers. And now I have to configure IP on router interface as well. So let's say IP address on this interface. IP address that you will configure on 0/0 will belong from the same subnet, right? So PCs are also using IP address from 10.1.1.10.1.1.0 network. So this interface will also use IP address from that network only. So let's say 10.1.1.100 is IP address of router interface. And on this interface, IP address is 20.1.1.100. Just suppose. So guys, when you will configure these IP address on router, see, by default interfaces or ports of switches are up, right? You can see green LED. Green LED means these ports are up. So by default, all ports of switches are up, but all ports of routers are down by default, right? So on router, you have to run one command, no shutdown on the interfaces of router, right? To up the interface. And you don't need to run this command on switch interface, because by default switches interfaces are up and router interfaces are down. So that's why you are able to see here red LED, and on this interface of switch as well, because line protocol of this interface is down. That's why you are able to see red LED. Line protocol means neighboring device. Who is the neighbor of this switch? Router. And router interface is down. So that's why this interface is also down right now. Once I will run no shutdown command on this interface, automatically this port will come up, right? So see, this is my router. I have access of router. Now if I want to run no shut command on 0/0, or I want to configure IP address on 0/0, first of all I have to enter on the interface. So as I told you in last class also, that first command you will run on router is what? Enable. This is, guys, first configuration. First time I am configuring router. So first of all I have run command enable. Now I am in privilege mode. Here I will run configure terminal command. Now I am in global configure mode. Now I need to go to interface. So I will run command interface. The interface type is fast Ethernet, and the interface ID 0/0, right? So now I am on fast Ethernet 0/0. Here I can run command what? No shutdown. So once I will hit enter, this port will come up. You can see now port is up, and after 30 seconds this port will also come up. Now why after 30 seconds? You will learn in spanning tree protocol, STP. Why it's taking 30-second time? Getting my point? So now guys, this interface is done. See, after running no set command here, I'm getting one log message as well, like interface fast ethernet 0/0 change state to up. Line protocol, for the line protocol also there is one log message. So we will read this log message later when we will discuss log messages, guys. Don't worry, leave it for now. This is just a log message. So for now, what you can keep in mind, that whenever we will configure anything on router, or whenever an event will occur on router, router will generate a log message, and that log message is very useful for troubleshooting. Like you can use these log messages for troubleshooting the router, right? So in upcoming day, we will understand log messages and how to store these log messages on a centralized server. So from that centralized server, you can check the log messages, and through that you can troubleshoot the router, right? And now on in this interface, guys, I can configure IP address. And before configuring IP address, if you will check the routing table, command I can run over here is do so IP route. This is the command to check routing table of a router. See, is there any entry? No. But once I will configure IP address 10.1.1.100.255.255.255.0, I have configured the IP address over here, and this interface is up also. So now again I am going to check routing table, do so IP route. You can see there is one entry. What it's saying, this C stands for connected. So it's saying 10.1.1.0/24 network is directly connected on fast ethernet 0/0. Means if this router is going to receive any traffic where destination will be from this network, right, it will forward that traffic from fast ethernet 0/0 interface. Clear? In the same way, guys, when I will configure IP on fast ethernet 0/1, on this interface also I'm going to run no set command first. Now this interface is up, and then I can define one IP 20.1.1.100.255.255.255.0. Now again this router will make one entry in the routing table, so IP route. Now you can see there are two network. One is 10.1.1.0, another one is 20.1.1.0. 10 network is connected on which interface? On 0/0 interface. 20 network is connected on which interface? 0/1 interface. This is by default behavior of router. I have not configured anything. I have only configured the IP address. So when I am configuring an IP on interface, router is maintaining a table, right? Router is making one entry in their routing table, and it will use this routing table to forward the traffic. 1 second. So this is, guys, router for now, right? Later on we will discuss more about the routing table. Like in the routing table there are many more information, right? Here you are not able to see many information, but there are some information as well. Like you can see two subnet mask, two subnets. And if you will open a network, you know, in detail, let's say 10.1.1.0/24, like this. Yes, you can see now you have some extra information about this network, like traffic share count, metric is what? 0. Exit interface fast ethernet 0/0. Metric is 0, distance is 0. So you have to learn these things, like what is metric, what is distance, right? Non via connected, what is the meaning of it? Getting my point, guys? So there are lots of things under routing table that we will cover later. For now, just I am, you know, trying to make you understand router. What is router, and how, what is the basic function of router? Basic function, like how router is going to perform unicast thing. That's it. So is it clear? If yes, please let me know.
Yes.
Good. Now I want to provide internet to this user. What I need? what I need to do, guys, I need to connect this network, this router to internet. Yes or no? ISP. So let's say there is one ISP, and between router and ISP I need to insert one more device. Which device? Firewall. Very good. So next device is what? Firewall. Again we are going to discuss basic things like router, like switch. That till now we discussed what, guys, about the router and switch, that how switch is going to perform unicast, which table switch is going to maintain to forward the traffic, which table router is going to maintain to forward the traffic. And in the same way on router you can check ARP table as well, like so IP ARP. So you can see router is also maintaining ARP table. There are two entry IP address, they are on IP address. So in Windows operating system is not maintaining their own IP address and on MAC address, but Cisco IS is maintaining their own IP address and on MAC address also in the ARP table, right? These two are their own entry. When it will receive any traffic, let's say from the PC0, definitely it will learn the MAC address of PC0. Ping 10.1.1.100. Ping is working, and now if you will check the ARP table of router, you can see it have learned the MAC address of 10.1.1 also. This is MAC address. And on which interface? On this interface, right? And how to check routing table? So IP route, that's it. Now try to understand the firewall, right? Now I can connect this firewall. What is saying? The cable can't be connect the path. Okay. What cable I am using here?
Route has only 2%.
I'm using, by the way, automatic cable, so it should use. Actually, problem is what, on router we have only two interfaces. So what I can do, I can add one interface, one more interface over here. Like let me add power is on. So whenever you need to add module, first of all you should turn off your router, right? So I have turned off it. Here is the button. You can see power is on, and if I will insert any card over here, let's say this card. So what it's saying, device can't add a module when power is on. So first of all you have to turn off the power, and then you can add this module is not compatible, right? So this module is not compatible with this slot. So what you can do, you can add another one. This one is I think, yes, this one, right? I've added some extra port over here, and the cable, what is the issue? So we have Giga Ethernet port over here, it should use this cable. Just wait, give me a second. Okay, like this. Actually, on this router, we don't have any Giga Ethernet port. Okay, and then we can connect firewall to ISP, internet. So guys, like switch maintain MAC address table to forward traffic, like router maintain routing table to forward traffic, firewall is going to maintain a table, and that table is called connection table. That table is called connection table to forward the traffic. Firewall is going to maintain which table? Connection table to forward the traffic. Okay, so let's say if this PC0 want to communicate with PC5, will my traffic go via firewall? Will my traffic go via firewall, guys?
No.
No,
sir.
because both are my inside user. So whenever my inside user will communicate with each other, right, there is no role of firewall. Like if these devices want to communicate with each other, there is no role of router. If these devices want to communicate with each other, there is no role of router. But if these devices want to communicate with these devices, right, they can communicate via router only. In the same way, if these user or these user want to access internet, they have to communicate via what? Firewall. And whenever, let's say on the ISP, there is one server whose IP address is 8.8.8.8. IP address of this PC is 10.1.1.1. So when this PC will ping to 8.8.8, 8.8.8.8, right, it will forward traffic to switch. Switch will do what, guys? After receiving the packet on 0/1, when switch will receive the frame, what switch will do? First thing, the very first thing, what switch will do? It will learn the source MAC, correct? It will learn the source MAC address. It will make one entry in their MAC address table. Then it will check destination MAC. Again, it will find destination MAC in their MAC address table. If there is entry available, it will forward the traffic from a particular interface. If entry is not available, it will do broadcast, right? So let's say it have entry and it have forwarded to router, right? Now what router will do? Router will check their routing table, right? First router will check destination IP. So destination IP is what? 8.8.8. It will check their routing table. Will there any entry for 8.8.8 in the routing table of router?
No.
Can I configure an entry for 8.8.8?
Yeah.
Okay, yes, you can configure, but guys, try to understand this is not practical, because like 8.8.8, there are million of server on internet, yes or no? So you cannot configure million of route in the routing table of router. Your router don't have capability to maintain million of prefixes in their routing table, millions of network in their routing table. You know, max to max your router can maintain 1,000 number of routes in their routing table. If this router is normal router, right? I'm talking about the normal router. So here we cannot configure lakhs of prefixes, lakhs of route in the routing table of router. But you know what I can do? I can tell to my router that whenever you will receive a traffic, right, and you don't have route in the routing table, if that route, that destination is unknown for you, then do one thing, please. Then forward all that traffic, all those type of traffic towards firewall. That is called default route, right? So when router will receive a traffic where destination is 8.8.8, first it will check the routing table. If route is not available for 8.8.8, it will simply forward the traffic to what? To whom? To firewall. To firewall, right? So we will understand how we will add default route, how we will tell these things to router, don't worry. After that, router will forward traffic to firewall. Now what firewall will do? See guys, when I will place the firewall over here, first thing that I will tell to firewall is what? First of all, I will tell to firewall that this is your IP address on this interface, this is IP address on this interface, right? Then I will tell to my firewall, brother, this is your inside interface and this is your outside interface. Once I will tell to firewall, brother, this is your inside interface. Firewall will came to know that this interface is my trusted interface. What? This interface is trusted interface. Getting my point? Because inside interface is that interface which is connected with your private network. Your private network. And once I will tell to firewall 1/2 is your outside interface. Firewall will came to know that this interface is what? Untrusted interface. Untrusted. Now firewall will start trusting on this interface and will start untrusting on this interface. Firewall is not going to trust any traffic on this interface. Firewall is going to trust all traffic on this interface. Is it clear? First, PC will forward traffic to switch. Switch will learn source MAC address. If MAC address is already there, it will update the entry. Then again it will check their MAC address table and it will forward traffic to router. Router will check the routing table. It will compare the destination IP address. If the route is available, it will forward traffic from the exit interface. If route is not available, it will forward traffic to firewall. When firewall will receive traffic on inside interface, right, on the trusted interface, who have told to firewall this is your trusted interface? You. Also, you will say this is inside interface, right? You will configure this command interface G1/1 name if inside. That's it. Once you will run this command, firewall will come to know that this is inside interface. It will set security level 100 over here. Security level 100. Don't worry, we will discuss the security level in firewall. Right? So router will start trusting on this interface. Correct? Now whenever a firewall will receive traffic on trusted interface, it is going to maintain one table. That table is known as connection table. Clear? Firewall is going to maintain a table called connection table. In the connection table, it will add source IP and destination IP. In the packet, source IP is what? 10.1.1.1. Destination IP is what? 8.8.8.8. Now firewall have knowledge that I have sent one packet to 8.8.8. From which source? From 10.1.1.1. And then firewall will forward traffic to ISP. When the server will generate reply, source is going to be what? 8.8.8.8. Destination is going to be what? 10.1.1.1. Right? Now when firewall will receive the traffic on outside interface, on trusted interface, now this interface is untrusted, right? Not trusted, outside interface. So firewall is not going to trust on it. Firewall is going to check what? Connection table. If there is entry in the connection table, then only it will allow the traffic. So yes, entry is there or not, guys? Yes, entry is there, right? For 8.8.8. So firewall will forward the traffic to router, and again router will forward to switch, switch will forward to PC. But try to understand, when there is one more server whose IP address is 3.3.3.3, who is going to, this is attacker, let's say. What? Attacker. This attacker is going to send one virus to, let's say, PC0, one virus. So if PC0 will receive that packet, right, once this PC will click on that packet, right, virus will install there, and it will corrupt the, let's say, PC, or it will corrupt the server, right? So this attacker have generated one packet with source 3.3.3.3, destination 10.1.1.1. It will forward to whom? Firewall. Now firewall is receiving traffic on which interface? Outside interface, correct? Outside interface means on untrusted interface. It is going to check what? Connection table. Is there any entry available, guys? No. It will discard the traffic. This is how firewall is going to work. Is it clear? Right? So switch maintain MAC address table, router maintain routing table, and firewall maintain what? Connection table. How firewall is going to build connection table? Whenever it will receive traffic on trusted interface, it will make one entry there, correct? And whenever it will receive traffic on outside interface, it is going to compare in the connection table. If entry is already there, then only it will allow, otherwise it will discard it. Okay.
So automatically the interface inside of the firewall will be trusted.
LAN site, yes, this is trusted. So here, as I told you now, on this interface you will run this command name if inside. Once you will run inside, firewall will came to know that this is trusted interface. It will set security level 100. Once you will configure this interface as outside interface, firewall will came to know this is untrusted interface. It will set security level 0 over here. And traffic, by default, traffic from higher security level to lower security level can flow. From traffic from lower security level to higher security level can not flow, right? Okay, now guys, till now we discussed networking devices like PCs, switch, router and firewall. Next device is what? AP. So right now I am not going to discuss more about access point, because access point is similar like your switch. In the same way, AP is also going to learn MAC address. It is also going to maintain MAC address table, and it is going to forward traffic. It is going to perform unicast communication like switch. Okay. So now hope I am expecting you guys are familiar with these networking devices. Okay. And here in the packet tracer you have some servers as well. Like if you want to use servers, because in upcoming day we will configure this server as well, right? Maybe we will configure DHCP service on the server, DNS service, HTTP service. Like I can configure this server as Google server, right? And then we will see how I can access multiple resources on this server, right? How these user can access the resources on the server which are available on server, right? Don't worry. So this is basic structure of network, and now hope this structure is clear to you. You are familiar with these all devices, right? So till now we are here. Networking, advantage, types of network, components of network, types of communication, modes of communication, and networking devices. We discussed NIC, we discussed hub, we discussed switch, we discussed router. Any question in these devices and firewall as well? Any question guys till now?
I have one question.
Yeah, go ahead.
You said that on like when you connect the router or the switches, but you said that like the interfaces. So the zero, let's say you have 0/1. What did you say that it meant again? You said that it mean?
Can you repeat? I didn't get your question. Like what? What you are saying?
Certain port number is I think.
What certain port number?
Yeah, like you said 0/0/1. You said yeah.
0/1 means what? Slot number 0, port number 1. Let's say 4/1 or 8/9 means slot number 8, port number, sorry, slot number 8, port number 9. Like on a router, see this router. See this router, brother. Where is my router? Yes, this one. Let me copy this image again. Yeah, already here. See, let's say what, this is slot number 0, right? This is port number 0, this is port number 1. So what will be interface ID of this port? 0/0. What will be the interface ID of this port? 0/1. Let's say this is slot number 1 and port number 0, again port number 1. So what will be the interface ID of this port? 1/0. What will be the interface ID of this port? 1/1. First number is showing what slot, second number is showing what port. In a slot, see, this is my router, right? Let's say on my router there are 4 slots. So in these slots we can insert what? Cards, right? Cards with ports. Let's say you have one card with 2 ports. So you can insert this card over here in this slot, right? And this is, let's say, slot number 0, this is slot number 1, this is slot number 2, this is slot number 3. So if you will insert this slot over here, what interface ID this port will get? 0/0. What interface ID this port will get? 0/01. 01, right? If you will insert this slot, this card over here in this slot, getting my point, then what port ID this port will get? 3/0. this port 3/1. Getting my point? Like this it's working. Clear?
Yeah, perfect. Yeah, clear.
Any other question till now? Okay, guys, any improvement in the class? How class is going on? Are you guys getting me or not? Or any improvement is required? Please let me know. Like I should go slow, I should go fast, I should not discuss basic, I should only discuss advanced, or I should discuss basic as well as advanced. Tell me like this.